So how exactly do we find the percent compositions of all the elements inside of chromium 3 acetate? Well, the first step is to find the molar mass, and then we can find those percentages very simply. And I'm going to use this table to help us out. Bam. So the first thing I'm going to do is write down the element I see in the compound, right? So I see a chromium, I see carbon, I see hydrogen, and I see oxygen. Next then is to write down the number of atoms of each, and that's where the subscripts come into play. So at chromium, there's an invisible one there, so that means that there's one chromium atom. For carbon, there's 2 carbon atoms, but that's in one acetate. You have 3 of them. 3 of those acetates meaning. So therefore you would have a total of 6 carbons, right? All you have to do is just take that subscript of carbon and then multiply it by the outer subscript to find the total. So that would simply be 6 carbons. Same thing for hydrogen. Take the subscript of hydrogen, multiply it by the outer subscript, so that's 9. And then oxygen, same thing. Multiply those 2 values, so that's 6. Then we're going to take those number of atoms and multiply it by the mass of each element. Where do we find that, you ask? Well, good question. Periodic table, so let's check it out. Here's all the masses. 52 for chromium, 1.01 for hydrogen, 12.01 for carbon, and oxygen is 16. Those masses represent molar mass in gram per mole or molecular mass in AMU. All right, the magnitudes are the same, but the units are different. But quite honestly, who cares? Let's just plug it on in. So chromium is 52, as we mentioned. Carbon is going to be 12.01. Hydrogen is going to be 1.01, and oxygen is 16. Now, all we have to simply do to find the total mass of each element in the compound, we just have to simply now multiply this row and across. So the total mass of chromium in that compound is going to be 52. The total mass of carbon is going to be 6 times 12.01, which works out to be about 72.06. Then for hydrogen, same thing, multiply it on across, that's 9.09. And then oxygen, again, 96. To find then the total mass of the entire compound, all you literally have to do is now just add up this particular column. So when you add that up, you get a total mass of 229.15. So now remember, that was the first step of finding the percent compositions. We had to find the total mass, right, of this compound, which we just did. Now all I'm going to do is add a nice little column to this table, and it's going to be very, very simple from here. Bam. So now all we need to do is take that mass of the element that we found, the total mass that is, so for chromium it's 52, then divide it by the total mass of the entire compound, hence why we had to do that first, and then multiply it by 100. This is a simple percent calculation, part over whole times 100. So when we calculate that, it works out to be about 22, let me make that a little neater, 22.69%. And that's the percent of chromium in chromium 3 acetate. Same thing now for carbon, right? Take the total mass of the carbon, 72.06, divide it by then the total mass of that entire compound, times that by 100, and we get our answer of about 31.45% or so, right? That's the percent now of carbon, percent by mass that is, right? And then hydrogen, same thing, take the total 9.09, divided by then the total mass, 229.15, right? I think you're seeing a pattern here. And then that works out to be about 3.97%. Last but not least, oxygen, right? This becomes a little monotonous and boring after a while, but that is a good thing. That means it's easy, and we want it to become easy, right? So 41.89%. Now, if you've done this correctly, these percentages should add up to 100. That just tells you that you found the right percents, but you still might have made an error in here. But, you know, just be careful in the work. But it's really not that bad, right? Fairly straightforward. You can always follow this exact process anytime you need to find percent composition. Guys, thank you so very much for tuning in. Appreciate it. I'll see you in the next video. Be well.